We're going to be talking about finding the number of solutions to a system of equations. And there's going to be three different types of answers you'll see. So the first answer you're going to see is where you have the lines intersect at one point. And this is going to show us that we have exactly one solution. The one solution that we would be looking at would be this point right here. That's where the lines intersect. That's where they cross. Some things we want to make sure we look at is with the equations, are the slopes different? And is the y-intercepts different? Because this is going to be indicators that's going to tell you that these lines will cross and there's going to be exactly one solution to that system of equations. If we're looking at infinitely many solutions, that means that we have one line. So we have one line here. And then when we actually graph the second line, they overlap. They're the exact same line. And that's important to remember, is that they're going to be the exact same line. It's going to tell us that every single one of these points on these lines would work as an answer to the system of equations. So some things to look at are that the slopes of those lines are the same and that the y-intercepts are the same. Okay, those are going to be indicators that we have infinitely many solutions. And then the last one we have here is we have parallel lines or no solution. Okay, this is going to show us that these lines that we have this line here, and we have this second line here. These are parallel, and if we remember from parallel lines, they never cross, they're never going to meet, they're always going to run side by side forever. And that's going to show us that there's going to be no solution. There's going to be no point where these two lines are going to cross one another. Some indicators are going to be that the slopes are the same, but then the y-intercepts are going to be different. Okay. Now, in the examples we're going to look at, we're not going to have a graph. We're just going to have the equations that we're looking at. So it's really important that we're looking at one solution that we're checking to see, are the slopes different? Are the y-intercepts different? For infinitely many solutions, we want to check to see, are the slopes the same and are the y-intercepts the same? And then for no solution, that's where we're going to look to see if the slopes are the same, but the y-intercepts are different. So this is going to be kind of a good indicator, a good key that we're going to use when we're looking at these systems of equations for practice. A system of two equations can be classified as follows. If the slopes are the same, but the y-intercepts are different, there will be no solution. If the slopes are different, and this system is going to have one solution. So if there's one solution, we really need to just look at the slopes, and the slope is going to tell us if they're different, that means there is only one solution. If the slopes are the same and the y-intercepts are the same, this system is going to have infinitely many solutions. So let's look at some examples of this. Let's take a look at this first one. So how many solutions does this system of equations below have? And we're looking at these two equations. We have y equals negative 8x plus 3, and we have y equals negative 3/4 x plus 5/6. And we have to decide, is there no solution, is there one solution, or is there infinitely many solutions? So the first thing you want to look at is we want to check the slopes. Check the slopes. Okay, and remember an equation is written in slope-intercept form if it's written as y equals mx plus b, where our m, the value in front of the x, is going to tell us what the slope of the line is, and then our value that's at plus b is going to tell us what that y-intercept is going to be. And so that's the first thing we want to do with this, is we want to check the slopes, okay? So we're going to check this number that's in front of the x. And so our slope of this line is going to be a negative 8. And our slope of this line is going to be a negative 3/4. And now we can see here that the slopes of these lines are different. Slopes are different. And that is going to tell us that because the slopes are different, these lines will intersect if we graph them. So they intersect at one point, which means that we're going to have one solution to this system of equations. Okay, let's look at a couple more examples of this. Our next example here says, how many solutions does the system of equations have? And we have y equals -9/5 x plus 7/9. And then we have y equals -9/5 x plus 6/5. And so the first thing we want to do again is we want to check the slopes of our lines to see, are they the same or are they different? So if we have y equals mx plus b, we're going to look at the slope being that number that's in front of x. So the slope of this line will be a -9/5. And the slope of this will be a -9/5. So that's the first thing that we're going to see here with this set of equations, is that the slopes are the same. Okay, so the slopes are the same. So since the slopes are the same, that automatically is going to eliminate our answer choice of one solution. Remember, if it's one solution, the slopes are different. And so now we can kind of move on to our second step, where now we need to check the y-intercepts. Okay, the y-intercepts, if they're the same, it's going to tell us that we have infinitely many solutions. If they are different, it's going to tell us that we have no solution or we have parallel lines. So we're going to look at the y-intercept of both of these equations. So the y-intercept of this first one is going to be plus 7/9. And the y-intercept of the second one is going to be positive 6/5. And I'm just going to write this as 6/5. And just to be clear, that the y-intercept is this number that's in place for plus b. So this would be our y-intercept. And it's not always going to be plus b. It depends on if there's a positive sign or a negative sign that goes with the number. So we can see here we have one of our equations has a 7/9, and then the other one has a 6/5, which those are not the same fractions. Those are not equivalent fractions. They're not the same number. And so we can say the y-intercepts are different. And so because the y-intercepts are different, but the slopes are the same, this is going to tell us that we have parallel lines. Okay, they are parallel lines. If they were graphed, they would be parallel and they would run side by side forever, and they're never going to cross. They're never going to meet. There's never going to be a point where they intersect. And so that means that in this question, we're going to have no solution to the system of equations. If the y-intercepts were the same and the slopes were the same, that's where we would say we have infinitely many. But since the slopes are the same, the y-intercepts are different, that's where we'll say there is no solution. All right, let's keep going with a couple more examples. So again, we want to decide how many solutions does this system of equations have? And we want to decide by looking at the slopes and the y-intercepts of these lines. So first, we're going to check the slope of the line. And when we do so, we have to make sure we're looking at slope-intercept form. And so the slope is going to be that number that's in front of x for m. So this would be our slope. And so the slope of this first line, we can see, is going to be 7, positive 7. The slope of our second line is going to be -8/3. And notice too that it's the whole fraction that goes with in front of the variable, okay? So in front of that variable of x, that whole number. So if it is a fraction, you're going to write the exact fraction. And if it's just a whole number of 7, you would just write that whole number. That would show us, that's going to tell us what the slope of that line, if we graphed it, would be. And so in this case, the slopes are different. And you might remember from that first example that we completed that if the slopes are different, it's going to tell us that our answer is going to be only one solution. If the slopes are different, it's going to tell us that at some point, if we graph those lines, some point those lines are going to cross and they are going to have that point of intersection that is going to be our solution to the system of equations. All right, we're going to keep going. A couple more examples. How many solutions does this system of equations have? And we have y equals negative 10x plus 8, and we have net y equals negative 10x plus 3/8. And just looking at this, some of you might have already kind of looked at it and thought of the answer of what it would be. But it's important to go through those steps of the first thing we want to do is check the slope. And then if we get to the point of the slopes are the same, then we would check that y-intercept. We're going to use our slope-intercept form of y equals mx plus b, where our slope is our value in front of x, or the value substituted for m. And then our plus b is going to be our y-intercept of the line. So the first thing we're going to look at is the slope of each of these equations. So the slope of the first line is going to be this number, negative 10 in front of x. And notice too that the sign that goes with that number is going to go with the slope, okay? So for instance, we have a negative 10 in front of x, and so that whole term of negative 10 will be used for our slope. Same thing with the second equation, we have a negative 10 in front of x, so that whole term will be used as our slope. So the slopes of these lines are the same. Slopes are the same. Now, process of elimination, we can eliminate one answer choice just knowing that the slopes are the same. We know that in order for there only to be one solution, the slopes need to be different. So we would eliminate that as an answer choice. It's not going to be one solution. It's either going to be no solution or it's going to be infinitely many solutions. And then we can move on to, now we want to check the y-intercepts of those equations. So the y-intercept of the first one would be this plus 8. Okay, you could write plus 8 or you could just write 8. Remember, if we just write the number 8, it is, automatically a positive. And then the second equation, we can look here and we have a plus 3/8. So we can see here that one of them we have a positive 8 and one of them we have a plus 3/8 as a fraction. And so the y-intercepts are different. And this is going to tell us that we are going to have parallel lines. If we graphed these, we would have parallel lines, which means there would never be a point where these two lines would cross. They would never meet, they would never intersect. They're always going to run side by side forever, which means that our answer would be no solution. If it was infinitely many solutions, that's where we could say that it's the same line. It's the same slope, same y-intercept. All right, just a few more examples to practice. These are going to be a little bit more challenging. Couple more steps with these, because as we can notice from just looking at both of these equations, is these are not written in slope-intercept form. So they're a little bit difficult to picture if it's going to be no solution, one solution, or infinitely many, because how do we figure out what the slope is? How do we figure out what the y-intercept is in the format that we have it in? Okay. We still want to make sure that we check the slope and we check the y-intercept. And so one thing that I would encourage is I would encourage you to rewrite this as to be in slope-intercept form, okay? That way we can clearly see that our slope is the number in front of x and our y-intercept is the number in front of, or I'm sorry, not in front of, in place of plus b, okay? And so looking at these examples, we can see that this is not placed in slope-intercept form. And so how do we get this in slope-intercept form? Well, we want y to be by itself. And so we're going to look here. We have negative 2x minus 5y. So we need to get this 2x to the other side somehow. And in this case, when we do move it, we need to use inverse operations. And so since this is a positive 2x, we're going to subtract 2x. And then we also want to subtract it over here. Now, looking at this over here, we have a negative 4 minus 2x. These are not going to be like terms. And so there's nothing we can do except for just rewrite this as negative 5y equals, and I'm going to write this as negative 2x minus 4. Just rearrange those terms. But notice that the negative sign still goes with the 2x, and then the negative sign still goes with the 4, so it still has the same meaning. We still want to get y by itself, and we have this coefficient of negative 5 attached. So in order to do so, we're going to divide the whole equation by negative 5. And what that does is cancel the negative 5 out over here, and it leaves us with exactly what we want. It leaves us with just y equals negative 2 divided by a negative 5. We could change this to a positive 2/5 x, and then negative 4 divided by negative 5 is just plus 4/5. Remember, a negative and a negative, the signs are the same. If we're multiplying or dividing, if the signs are the same, then we're going to have a positive answer. So we've rewritten this in slope-intercept form now, and we can clearly identify that the slope now is 2/5, this number in front of x, and then our y-intercept is in place of b, which is a positive 4/5. So it's much easier just to be able to pick out what is my slope, what is my y-intercept, if it's written in slope-intercept form. So now we can do the second equation. We've got 6x minus 15y equals negative 12. So again, we want to get y by itself. Okay, so in order to do that, we're going to use inverse operations to move 6x to the other side, subtract 6x from both sides. And this will cancel for us over here. And then over here, we would still have negative 15y, but negative 12 minus 6x, we can't combine those terms because one has a variable and one does not. And so we would leave this as minus 6x minus 12. And then we've got negative 15y. We want to get y by itself, so we're going to divide the whole equation by this coefficient of negative 15, which would cancel this over here, leaving us with exactly what we would like of just y by itself. And then we'd have negative 6 over negative 15. We can reduce that. Remember, we want to reduce our fractions the best that we can. So we could say 3 divide both by 3, and that would give us, it is going to change to a positive because we have a negative and a negative. So it's going to be 2/5 x. And then we would do the same with negative 12 over 15. We can divide both by 3, and we would get a positive 4/5. Okay. Now we can see clearly my slope is going to be 2/5, and my y-intercept will be positive 4/5. So when we look at this, let's first compare the slopes. Okay, so the slope of the first one is 2/5 and the slope of the second one is 2/5. So we could say our slopes are the same. They are the same number. And then we want to compare the y-intercepts. We've got y-intercept is equal to 4/5. And then for the second equation, we have got a y-intercept is equal to 4/5. So we can say these are also the same. And because the slopes are the same, again, we can process of elimination. We can say, okay, it's definitely not going to be one solution. No solution would mean that the slopes are the same, but the y-intercepts are different. And in this case, we have the slopes are the same and the y-intercept is different, and the slope, y-intercept is the same. So we would say this is an example of infinitely many solutions. These are the exact same lines. And this is where it's really important to convert that or rewrite those equations into slope-intercept form, because when we first looked at these equations, we had 2x minus 5y is equal to negative 4, and then we had 6x minus 15y is equal to negative 12. They looked like different equations. They looked like they were going to have different slopes and different y-intercepts. But when we rewrote those equations to be in the slope-intercept form of y equals mx plus b, we ended up with a result of the exact same line or the exact same equation. Okay, and that would tell us that there's going to be infinitely many solutions. These are going to be lines that overlap and they run together forever, and every point on those lines would work as a solution to the system of equations. All right, one more example, we want to look at one more example that's similar to this one that we just saw, where we're rewriting it to be in slope-intercept form. And so slope-intercept form is ry equals mx plus b. And we know our slope is going to be that number in front of the x, or the in place of m. And then plus b is going to be our y-intercept. And so first thing we want to do is we want to check our slopes. And then we want to check our y-intercepts to see, are they the same or are they different? So when we rewrite this, we want to get our y by itself. And so we're going to take the x to the other side, in this case by subtracting. So minus 7x minus 7x. And this will cancel over here for us. And then over here, we've got negative 5 and a negative 7x. One has a variable, one does not. So we cannot combine those. They're not like terms. So we're just going to rewrite it as negative 7x minus 5. Now we want to get y alone. So in order to do that, we're going to divide everything by negative 9. And you might be thinking, why did I pick negative 9? We're going to divide by whatever number is with the y to get it alone. So that means this will cancel. And then over here, we're going to have y equals negative 7 divided by negative 9. That would be now a positive fraction, 7/9 x. And then negative 5 divided by negative 9 would be a 5/9. We can't reduce these. There's no number that can go into both 7 and 9, and there's no number that can go into both 5 and 9. And so we would just leave this as the fractions we have. So now our slope of this line is going to be 7/9, and our y-intercept will be 5/9. And then we can move on to the second equation. We're going to do the same thing. We want to get our x to the other side and get y alone. So we're going to subtract 14x and subtract 14x. This can cancel on this side, but then when we look at the other side, the equal sign, we've got 1 and a negative 14x. We can't combine those. They're not like terms. One has a variable, one does not. And so we would just rewrite this as negative 14x plus 1. And then to get y completely by itself, we're going to divide everything by the number that is with y, which is negative 18. And that means negative 18 will cancel for us. And then we'll have y equals negative 14 divided by negative 18. We know it's going to be a positive. We can reduce this, though. If we think about 14 and 18, we can divide 2 into both. 2 goes into 14 7 times, and a 2 goes into 18 9 times. And then we can say plus, we have a positive 1 over negative 18, so this would just be minus 1 over 18 as a fraction. And you might be asking, why is it minus now when it was a positive before? And the reason why is because we're looking at these symbols, and we've got a positive divided by a negative. So remember, if the signs are different, it's going to be a negative answer. So that means our answer of 1/18 would be a negative number, or we could say a minus sign. So our slope of this line is going to be 7/9. And our y-intercept with this equation will be a negative 1/18. And so when we compare these two, compare the slopes first, we've got a slope of the first equation of 7/9, slope of the second equation of 7/9. So that means that our slopes are the same, which also we can eliminate that answer choice of one solution, because remember, one solution, the slopes are going to be different. So that's going to tell us this is going to either be no solution or infinitely many. So our y-intercept of the first equation is 5/9, and our y-intercept of the second equation is negative 1/18. These are different. These are not the same numbers, which means that this is going to tell us that we have no solution. The slopes are the same, but the y-intercepts are different. That's going to tell us that these are parallel lines, and that they are going to, if they were graphed, they'd be parallel lines, and they would run side by side forever, and they would never cross, they would never meet or intersect at any point to have a solution. Remember, infinitely many, it's the same slope, the same y-intercept. No solution is the same slope, but different y-intercepts.